Okay, so thank you so much for being so patient. So today, Ridwan that is supposed to lead the session today is now unfortunately unavailable. He can't join us today. So I'll be standing in for him and I hope I'll be able to cover some things fast. So we'll start with chapter 7. So hopefully can do some things here. Yeah, okay. Okay, so okay, for chapter 7, we're looking at importing and exporting data. So we're going to be using the package, a real package, which is actually flexible for the book. So for importing and exporting data, then we're going to use the hair package to locate files relative to an R project route. So then also the scenarios where we're going to be going through is going to be for specific Excel sheets. So we're going to handle messy headers and skipping some rows from the data that we're going to be importing. Then we're going to be importing also from Google Sheets, from data posted to the website with APIs, and then importing the most recent file, okay? Then manual data entry, R specific file types such as RDS and R data, exporting and saving files and plots. So without taking much of our time, let's go in. So, well, we're just going to look at the files. So basically, it's just this general norm of importing data. We are creating a new data frame object in the R environment. So when defining it as an imported file, either from Excel, CSV, TSV, RDS, R data, we're getting the data into our environment. So it's going to be located in our folder directories at a certain file path or address. So we can import many types of files, so including those created by other statistical programs. So it's not restricted to just these types. So it can also connect to databases as well. So R even has its own data format, that's the RDS and the R data file. So all this we're going to cover in this chapter as much as we can. So the package we're going to be using is RIO. So the name is an abbreviated version, kind of word from R inputs, outputs kind of interface. So that is what the package is going to allow us to do. We have access to the input and the output ports. So its functions, import and export, can handle many different file types. These are the examples: Excel, CSV, .rcs, .tsv. So when you provide a file path to either of these, RIO will read the extension and use the correct tool to import or export the file. So for those who are familiar with R, one thing we should know that there are so many packages for importing data. We have so many. The ones that come with the tidyverse package, the ones that come with the R base R function, and so on and so forth. So and other custom packages out there for maybe Excel, for CSV, and so many packages out there. But RIO gives us the interface to all the possibilities with all these different packages. So it's not about, okay, I'm looking for a package that will bring in only Excel sheets or CSV or TSV. No, RIO does all this for us. So by targeting the extension of the file. So the alternative to RIO is to use functions from many other packages, like I've explained. So the examples are OpenXLS, so reader package from the tidyverse package, okay? So then, okay, this alternative can be difficult to remember, whereas using import and export from RIO is easy. So that is the advantage that RIO has over all the other packages there. So RIO's function import and export use the appropriate package and function for a given file type. So can see the end of this page for a complete table, okay, of the functions that are within the real package. So so importing and exporting of shape files requires other packages as detailed in GIS basics. There's another chapter for this, so we're not covering shape files here. So we're going to, that would be covered in another chapter, that's the GIS basics. I'm not sure the page, okay, yeah, chapter 28. So that is where we're going to deal with that. So the hair package now, this is the a supporting package that we're going to be using. So the package here and its function here make it easy to tell R where to find and to save your files. In essence, it builds file paths. So we're going to use, so it's used in conjunction with an R project. Here allows you to describe the location as to the files in your R project in relation to the R project's root directory. So just like the name of your project itself. So this is useful when the R project may be shared or accessed by multiple people or computers. So we're talking about relative paths to your R project. This is different from maybe you just create an R script and you just dump it in your documents folder and you have the file data somewhere different. Everything's scattered all around. No, we're talking about an organized R project that you created using R Studio. So that path, okay, sorry. Okay, sorry, can you still see the browser? My browser, sorry.
Yes.
Can you see my browser? Sorry, kindly confirm.
Yes, yes, yes.
Oh, okay, okay, thank you. So so it's about an organized R project structure. This is where the hair package will be able to help you. So to create that relative path to the files in your project. So if you share the whole project with somebody else, irrespective of where they place the project folder, maybe the documents, downloads, desktop, whatever it is, it's going to still be able to create that path and everything will work perfectly well the same way. So this is how here works within an R project. When the here package is first loaded within the R project, it places a small file called .here in the root folder of your R project as a benchmark or anchor. Okay, so let me, I just downloaded this, so let me make sure. Control S, I'm correct. So I'll take it to my R Studio. I'll save this script. CH07, I think, script. Okay. So library. Yeah. Okay. So I can see that here, but let's get to the book and see. Okay, so let's read that again. So it places a small file called .here in the root folder of your project as a benchmark or anchor. So let's assume that is done. So in your scripts, to reference a file in the R project subfolders, you use the function here to build the file path in relation to that anchor. So to build the file path, write the names of folders beyond the rows within quotes, separated by commas, finally ending with the file name and file extension as shown below. So here function, file paths can be, with the here function, the file paths can be used for both importing and exporting your file and data. So for example, below, the function is being provided a file path constructed with here. So this is what we have. Let's copy this. I hope this would work with the repository that I put. So I will do this. So let's hope that works. No such files here. Okay, let me confirm. I need it. Okay, this data. The line list folder. Oh, okay, yeah. There's no folder with the name line list here. Okay, then Ebola line list. Let me see. Ebola. I mean, the data is not actually wasn't downloaded properly here. So let me see if I can quickly fix this. I'll pause the recording now. So while I'm trying to download the data, we'll continue with the book. So the command this is actually providing the full path, full file path that is unique to the user's computer. So it's going to be like this. So this is just like an example. So if I have my project file, let me go to RStudio. So let me get my working directory. So with this, all we're going to get, if we have our project folder set up properly, what I'm going to have now is going to be something like this. So it's going to give us a path. The function here is going to give the path like this. This is going to be like an example. And so this one is going to be data /line list. I hope I got that right. Then /Ebola underscore line list dot xlx. No, sx. Okay, so this is going to be the path, and the function import will now use this path to import the data into our environment. So we don't have to get bothered. So this is going to be generated automatically by the function, and is now going to append the remaining file path to it. So this will be different for every other person, but the here function is going to take care of that, irrespective of, provided you are using the same project folder, the R project, the same R project that is shared by everybody. So here we'll be able to do that. So you don't have to bother about, okay, I'm putting it on the desktop or I'm putting it on the my C drive. No, it's not going to be an issue. So let me comment this out. Then we'll go back to the book, and we hope we'll be able to pull that down fast. I'm not sure how long. Okay. Okay. I'm not sure. Let's hope we can get it done faster, or I use another down gates. Down gates someone. I want to see if I can download only the data. So use this one. Only the data. Okay, so I hope that is clear. So don't be bothered about the first aspect of the file path. So this is going to change for every other person. So it's going to be different. So when we get the data, we'll be able to see. Okay, awesome. I think this is done. Okay, I'll go for only the um, so I want to extract the zip folder now. Okay. Awesome. Okay. So all I need is this. Okay. So I believe there have been changes here. So this was corrected, kind of the case list here. So we're going to use a reference to this folder. So, and we're going to refer to the line list underscore raw. So as our own example, so that we can move on past this. So hopefully we can resolve this later, then we'll update the GitHub. So this is it. So now if you look at what we got, this is for Laura, while this this is what I would get. Just like I explained, you can see it's still the same. It's going to get my current working directory, then append this path, data / case line. So instead of line list, so we have case underscore line list, then we have line lists underscore row. So that's going to be our own example here. So I think we got that. So if we're not going to import, so this is not going to be difficult anymore. So anybody that picks up this, download this repo from the Abuja R user group GitHub repo, they're going to be able to achieve the same thing. The only difference is going to be our current working directory, which we can always test from your own RStudio. This is going to be the only difference. So whatever you get using this function get WD is going to be the only difference from what you see on the screen here. Okay, no matter where you place it, just make sure you are downloaded the entire repo and you have it on your system anywhere, either desktop, C drive, G drive, anywhere. Just put it somewhere, but make sure it's just the project folder. That's it. So I hope that is clear. So are you with me?
Yes, we are with you. I'm with you.
Okay, good. Okay, thank you. So now we've moved past this one. We've resolved that. So the file parts. So let's see what's there. So when importing or exporting data, you must provide a file path. You can do this one of three ways. Recommended, provide a relative path with the hair package. That means you are using the hair function from the hair package. Just simple hair. So, so provide a full or absolute file path. Okay, the manual file selection. So you can do that in three ways. So the relative path now is just like the examples we've done, the example we just did now. So we can do this as well. So if you copy this, it's the same thing as what the example here. So absolute file path, this you have to just put in the imports. So let me go show you that. I'll take you back to RStudio. So for the absolute part now, so it's going to be line. So line list. Let's just change the name here, raw. Okay, so bring in the import function from real package. Remember, it's not difficult. Just load your package. So here, so I've tried to bring up most of this real. So you could have used the Pacman, but I'm not using the Pacman because most of the functions they are still not running. So that's why I don't want to use this function for now, but you can always use the Pacman package function p_load to just bring it in, even if it's not installed. So I don't want to take much time because of internet here. So this is real, double colon. This is also here, double colon. So it's still the same thing. So just for you to know where each of the function is coming from. So here as well. So it's safe to put the package name because imports can be from any other package as well. Maybe it's loaded in the environment. So you want to play safe by referencing the actual function that you want to use. So for the absolute part now, all you just need to do is this. The import function has the argument file. So you put the double quote or single, then use your tab key. The tab key should be able to help us. So, but let me just start kind of semi-manual. So tab, this is not going through. Okay, it's coming up. Okay, kind of slow. So this, then tab, and this one. So that's the raw. So that's just like absolute path now. So this might kind of be an issue for somebody else to run because of the differences, but might still work. But just to be safe, you can just stick with this method. So it's still the same thing. So for the first one, the second one. So then the third option now. So a few things to note here. For the second option, absolute file path, avoid using absolute file path as they will break if the script is run on a different computer, just like I said. So use / like we did as in the example above, okay? So the file paths that begin with double slashes, okay, will likely not be recognized by R and will produce an error, okay? So you have to take note of that. Consider moving your work to a named or lettered drive that begins with a letter, e.g. J colon or C colon and so on and so forth. So see the page on directory interaction. So you can click on this link if you have the book. So let me just, in case you don't have the book, let me share that in. So this is it. Sorry. So now, okay. So one scenario where absolute file path might be maybe appropriate is when you want to import a file from a shared drive that has the same full file path for all users. So maybe a shared organization file path or maybe directory in the cloud or something that would work. So to quickly convert all this, highlight the code of interest and check the option box in selection and then use this. So then we'll go to the last option. Select file manually. You can import data manually via one of these methods. Environment RStudio pane. So click import data. Okay, so in the environment, you can click in and select the type of data. Then 2, click file back and then import data sets. Then you choose this. To hard code manual selection, use the base R function, R command this. So let's try this to select manually. So I'll just copy. So let's see if we can try that. So, okay. So we'll just try our best to bring things down, down. Then I'll comment out all this. Okay, so the first one, is saying that we should go to the environment pane. So this is the R2D environment pane. This one up here, it might be different on your own side there. So because you can change all these panes as you want. So just go to tools, global options, appearance, no, pane layout. You can change it from here. I hope you can see my pop-up. So you can decide to move your panes around as you want. So, but I'll leave mine like this. So this is my own environment pane. So this is the icon they're referring to, import data set. So if you click on this, we can select any of the file types that you're looking at. So from this one, I'm looking at Excel. Okay. So file paths, you can click on browse. So it's taking me directly to my R project repo. So I'll just say data, then case line, this, open, then it's going to give me this. So although I already have it, so it's just going to bring it in and it's replacing it there. So if I want to see it shown here, so let me just change this. Absolute. Let me just give it absolute. So I'll run this. So it changes that name. So we still have the raw there. So that one is for this. So if so one thing, this is already there. So I can just kind of, what would I say? Let me see if I can still remember this function. Okay, so let's see. Let me use this. So lists. Okay, no, let me see if I can get it out. Line lists row. Okay, it's gone. So that one is gone. So the line list raw absolute is still there. So I would do that again. The example, we'll go to environment pane, select the options from the import data sets. Go browse from the data, case line, and then the raw. So I'll just click import, then I'll have it here. So you can see it's now there. So the second option is to hard code. Okay, no, the second option is this. So we'll go to file. So click on file, we look for import data sets, then choose the options. So the same thing. So this is going to be what? So let's choose another data. Okay, but it's Excel. It has to be okay. Yeah, this is one. Line list cleaned. So I'll use that one. So import. So you can see line list clean is here. Okay, just another route. So then the last one, to hard code manual selection, use the base R function this. So that example is in the book. I'll go to the book, copy that example. So this is just a method that you can use. So go back to RStudio. Okay, so I'll just dump that here. Yeah. So if I run this like this, so there should be a pop-up. Okay, I'm waiting. Okay, so it's still kind of loading. I don't know why it's slow. So it's waiting. I'm waiting. Out. Okay, let me just stop. Let me hope I can stop it. So terminate that. Okay, while we're waiting for that, it's just an option. Let's go back to the book so that we'll use the time well. So we'll come back to that. So import data now. To use imports to import data sets is quite simple. So in this, so importing a CSV file. that is located in your working directory or in the R project root folder. It's just as simple as this. So you can choose to use the here function, or you just push it in like this, or you use the here function, having it at the back of your mind, I might be sharing this with somebody. Okay, so you can import a data frame. So a data frame, so okay, as a .rds file using an absolute path, just like the examples we had. So I am going to use this. Let's copy that. Then we just change based on the new folder structure that we have now. So okay, we're back to a fresh note. So let me just bring up the packages. So so if this is going to be kind of an headache, okay, yeah, the pop-up is here now. So sorry, let me bring it. Okay, the pop-up is faster this time. I don't know, maybe there was something running at the background. So if you run the line 20 of our code, you'll get a pop-up like this from your kind of directing you to your project repository. So you can just click on wherever your data is and just select something. So all these are which one should we choose now? So anyone, just that was not going to be so much. So that's the pop-up is closed now. So I think I should, okay, so this is my data now. So it will have those information there, although it's not going to be meaningful. It's just a dictionary information. So that is that. So let's try this. What I copied. So it's the same example, just like we have. So if I'm going to use this and making a reference to one of the data files that we have, let's go for the COVID example data. Okay, this one. So what I need to do, I already have the first folder as data. Then the second one is going to be COVID instead of line list. So it's going to be COVID underscore example underscore data. So that is the secondary info that I need to give for the folder where my data is going to be inside. So the first folder is the data. Then there is within the data folder a nested folder, which is COVID underscore example underscore data. Then the name of my file itself is what? So it's going to be COVID underscore example underscore data dot XLI. So that should be that. So let me just make it this as COVID. So COVID example underscore data. Okay, so this should give me the data. So that is it. So it's as simple as this. Just know that, okay, from the first folder, I'm going to the next folder, then the file itself. So it might be that maybe you don't even have to go through multiple folders. So that means you're going to have only the name of the file and its extension like this. So, but if you have it nested like we have now, you have to put those nested folders before separated by a comma. So any question at this point? If you have question or I'm going too fast, please, I just want us to use the time well. So we don't want to be repeating ourselves. So it's irrespective of the data file type, just use the import or any method that you want to use from how to select our files. Anyone is okay. So just make sure you're okay and you understand what you're doing. So that's just that. So important is all this. So these are examples. So specific Excel sheets. Okay, by default, if you provide an Excel this, so import to import function, the workbook's first sheet will be imported. Okay, good. So if you want to import a specific Excel sheet, include the sheet name to the which argument, for example. So now if we have, I don't know about any of the files, any of the folders, but the files, the Excel sheets, but I'm sure this is an example. Then if we have a sheet name with this name, then we can say, okay, we want to import file from this sheet. You know, Excel is can be created as a workbook with multiple sheets. So if you have sheet 1, sheet 2, sheet 3, or any named sheet, might be maybe patient name for the first one, or patient record, then disease information for the second sheet. Any other sheets can be available as well, but we are more specific about the patient's biodata. So that is the first one. Then we can reference to that, the name of that sheet. So that's just an example. So the real life one here is this. So I'll copy this and I'll just go on.
Yes, sir.
Sorry, is there any question? If you have a question, just ask. Okay, so sorry, hello. Sorry, please, can you just mute? Okay, sorry for that. So I'll go on. So this is the example we're looking at. We can just quickly go through. Let me go into the directory for the data. So I'll open up one of the. So this is just one sheet. Not sure which one. We're having multiple sheets there. So okay, sorry, I'm just trying to see if one of them, I'm not sure of the one that we have currently. So if I try this, I'm not sure if it would get everything. Okay, there's no reason for the backtick. So no such file. So that means the structure is different. So let me see if I can get something. I'm not sure what it is. So we resume. Okay, so we have an example here. So from the data folder, there's still another folder that is example. So example now. So don't forget separate with a comma or you have an error there. So where is the folder? This is the folder. So we're going to go for the hospital underscore line. I think that's the one. Yeah, this one. So hospital underscore line lists. This is having S here. So the first sheet now. So the first sheet, I have to open that again. I think Central Hospital. Okay, Central Hospital, I still remember. Awesome. So we're still on this. So bring that up. Sorry, please. I hope you're seeing my studio. Central Hospital. So if we are making a mistake, then we'll be sent back here. So what we are actually doing here is this. We first of all give the path to our Excel sheet. This is the path. So if I run this, we'll get the full path to the file. That's hospital underscore list dot xlsx. So that's the file that we're referencing, but we are particular about a sheet there. So this is the sheet that we're particular about. So hopefully we can get that. So let me just change this to hospital underscore line lists, not row. Okay. So if I run this, yeah, we didn't get an error and we got the data out. So this is the data, and let me confirm from the Excel sheet itself. So how many rows do we have? Records. Yeah, it's 455 as well. Same thing. So 455. So it's the same for 454. Okay, the header name, that's minus the header name, the column names. So that gives us 454. So that's that. So for multiple sheets, so I would go back to the book. So I think any question? So if you have question, just please ask. We're going to stop by 6:30 and call it a day for today. So to export a data frame from R to a specific Excel sheet and have the rest of the Excel workbook remain unchanged, you will have to import, edit, and export with an alternative package catered to this purpose, such as Open XLX, XLSX, okay? So you can get more information from these links. So that's out of the scope of this chapter. So if your Excel workbook is this binary format of Excel workbook, you may not be able to import it using real, okay? So consider receiving it as .xlsx or using a package like read XLSB, which is built for that purpose. So missing values, you may want to designate which values in your data set should be considered as missing. So as explained in the book, in the page missing data, okay, I show that page. So new page or something. So this is something you would want to check. Okay, it's chapter 20. So chapter 20 now. Okay, that's where missing data is. So, but we're not there yet. So what we're talking about here is this. There's some information in your data file that R or any function in R might consider as missing. So if they are blank, maybe cells in your data file, R will term it as NAs, that's missing values or not available, the data is not available. So if you don't want that to happen, the import function also gives you that power to change anything like that. So you can replace those missing values with any character. So that is what they're trying to say, and the example is just this. So any information that is missing will be replaced by this character or string, that's 99. You can now convert, if it's going to be a numeric column, you can now convert it to numeric value in R. So this will get that sorted out. So that's an example. Then here, any of the values missing, that's empty cell or single space in the imported data sets are converted to NA in R. So here the value 99 in the imported data set is considered missing and converted to NA in this. So, okay, obviously what I was saying here is this. is different from what we have in read underscore CSV. You can replace missing values with some characters. So, but here you have some values. That's what you're saying here. The value 99 in the imported data set is considered missing and converted to any in this. So you can tag anywhere the function import gets this value, it converts it to any. So R will understand that this is a missing value. So 99 would not be there, but it's going to be replaced with any. So that's what they're saying here. So here, any of the values missing, empty cell space in the imported data set are converted to any. So like this. So we are can basically assigning, telling the import function that anywhere you get this missing or an empty cell or a space, that is going to be considered as any for this one. So I'm not sure if we have missing values in, okay. Yeah, we have space here. So we have spaces. Let's go to RStudio to check what was done with those missing values. Okay. So the missing values, the spaces are kind of automatically converted to any's here. So if you can see my RStudio, you can see importing the first sheet, that's this sheet. We have some missing values here and they are automatically converted to any's. So let me bring this, kind of make it bigger so that you can see. So we have the missing values here, they are any's. So that have been taken care of. So, but if you want to kind of make it specific, let me go back to the book. So we can do the same thing as we have here. So I just have only NS. So I will use this one. So this is the example. I'll just Control C. This one. NS. Okay. So if this is this, I am just going to copy this, Control C, because I don't want to, although it would import the first sheet by default. That's what you're supposed to do. So NAs are going to be this one, like space. Okay, so if I run this, we're still going to get kind of the same thing. Okay, NAs. So they are just going to be replaced with NAs. It's still the same old stuff. So I'm not sure if there is anything like missing here. We would have said, okay, that's the missing value. So let me see, missing, nothing. There's nothing like that. So basically that is it. Except I can maybe use the age units. There it has years. Maybe we can consider that as missing. So if I change this to years, then run that. So I go back there. I think that should be, yeah. So I said years should be considered as missing values. That's why all the values here, they're now NEs. So that's just what we're trying to say. So for this case, only missing values are NS. Spaces are NS. So sorry. So spaces are NS. That's just what you want to. So a typical example can be maybe we're collecting data from a survey and we ask participants to optionally give us their age. So if they didn't provide anything, they just left it blank like that, we can put in something. Maybe we want to consider that space as missing. So then you have to say, okay, wherever we find space or an empty cells, that will be a vector that we're going to pass in as the argument for n is here. So anywhere there is empty cell or space, okay, or okay, maybe they can also say that um not disclosed, or maybe they want to say I don't want to give you my information or something. I've forgotten. So all these can be considered as missing. So you just pass those kind of values to the NS. So also going to skipping the rows, there are some rows that you might want to skip, maybe just for information's sake. Maybe they add a title to the sheet, which is going to occupy the first row, then we can take it out, or maybe more than one rows or something. You can take those out. So I believe that should be some of the examples here. So here is just one, the first row, okay? Provide the number of rows you want to skip. So unfortunately, skip arguments here only accepts one integer value, not a range. Oh, that's a setback here. But for read underscore CSV, I think we can take out multiple rows. Yes. So to skip import of specific rows that are not consecutive from the top, consider importing multiple times and using bind underscore rows from the dplyr package. See example below of skipping only row 2. Okay. So manage a second header row. Okay, sometimes your data may have a second row. For example, if it is a data dictionary row, as shown below, like this. Okay, this situation can be problematic because it can result in all columns being imported as character. So this is an example. Okay. So what are they saying now? So below is an example. So it's the data dictionary book. So remove the second header row. To drop the second header row, you will likely need to import the data twice. So that's a lot of work, but sometimes you have to kind of skip some of the exercises here. There's other options that you can use for that. So, but we're following the book just in case. So you can import the data in the order to store the correct column names. So import data again, skipping the first 2 rows, bind the correct names onto the reduced data frame, and so on and so forth. So the exact argument you use to bind the correct column names depends on the type of data file. Okay, so this is because we are using different functions for the different file types. So there are always a good side and a bad side to some powers that we have. So this is kind of one of the setbacks of real package. That's the import function. So you can follow these examples, then you will be able to do all this. So then from CSV, you can do this, names, save the true, this, and then you go back and import again. Okay. So that's a lot of work. So you can check the column names here. So make a data dictionary. So bonus, if you do have a second row that is a data dictionary, you can easily create a proper data dictionary from it. So this tip is adapted from this post. There's a post here, you can check it out by Allison. So you can check the post out and okay, oh, the link is actually not available. It's not found. So, but I think there are other options that we can use that we don't have to go through these tedious steps, and you can create the data dictionary. Okay, I think we would continue because I'm actually not prepared. I'm not so strong. I think I'm tired now. So please, let's call it a day for now. We'll continue. I'll talk to Ridwan. Maybe we can make up on the remaining aspect of the chapter. I would like to call it a day here. So if you have questions,
My colleague.
okay, go ahead.
Yeah, I just want to appreciate your tenacity and
Okay,
sincerely, I have
thank
been
you.
blessed. I actually started with you and coming to this stage, you have been wonderful. Thank you so
Okay.
much.
Oh,
Please,
thank you so
let's
much.
drop the repo,
Can you come out
introduction.
louder? I can't hear you clearly. Hello?
Let
Hello?
me have the video link when you uploaded it. Hello?
Okay, I'll do that. I'll share it. I'll share the link. Thank you so much.
Okay, thank you.
Okay, so
God
Rachel,
bless you.
you have okay, thank you so much. Thank you. Thank you. Okay.
Thank you so much, Bilkisa. This was really, really helpful. Appreciate you.
Okay. Thank you very much. Thank you. Thank you
You're
so
very welcome.
much.
Thank you.
Yeah. So we'll catch up some other time. We'll make up the video and then we'll share. So thank you.
Sounds good. Thank you so much. Take care.
Okay. Bye.
Bye.